deep, right? And keep warm because the weather is really strange. No, you see. Any questions or comments before we continue our study on chapter 13? It's good. Anybody begin to do the homework, by the way? Nobody? I shouldn't post the homework before the fall break, right? But anyway, maybe you can continue to begin to do that from this week. Okay, the first model we introduced for chapter 13, inventory management, is the EOQ model. So EOQ model is very useful if you are in the position you have to place the order. There's so many players in supply chain, you have to make this decision. For example, if you are in the retailer's position, definitely you have to decide when to place order, how much to order. Similarly, if you are a wholesaler or distributor, you also have to place order from your supplier or manufacturer. The only exception probably is the manufacturing. Because manufacturing, the major decision is not ordering. What is the major decision for manufacturing?
Demand.
Not really. What's their daily activity? Manufacturing is production, right? It's production. So when you are in the position as a manufacturer, the major decision you want to make is how much to produce, when to produce. That's a decision we will discuss after we finish this EOQ model. Okay, but for most of other players, the most important decision for them for inventory management is when to place order and how much to order. And we can answer this question if we satisfy the assumptions by the EOQ model, like only one product is involved, and demand is constant, and lead time is fixed. Then we consider to minimize this total cost. And only two parts we consider for this total cost. One is the holding cost, and another is the ordering cost. And then we know that here the red curve is the total cost line. So we have this point which will give us the minimize the total cost. Okay, that's our goal. As a business person, our goal is to minimize our total cost. Well, but how to solve that? It's a mathematical problem. How to find it? Even we know that from the field, that's a minimizer point. And then by using calculus, take the first derivative, and then you can solve that. I'm really curious, is there anybody in our class who can solve this derivative question? First, I have to say it won't be test in any exam or homework, but I'm just curious about it. Anybody in our session know how to solve this problem to get the Q optimal? No? Okay, think about that way. So let's write TC as a function of Q, right? TC is a function of Q. Agree? Right? Q is the only variable. All other parameters. So to get this equation, in fact, we just take the derivative. So TC prime Q. Take the derivative of Q. You don't need to write this down because it's not test, but if you want, you can write this down. So what's about the first term? Q over 2 times H. What's the derivative of this one? Anybody? Take the derivative of this one. Is I heard somebody say something. Is
Q?
1/2.
No, take the derivative for Q.
Oh.
AQH.
Yeah.
H over 2, right? Because it's a linear function, that's right. It's a linear function, so this is slope, right? Linear function times Q, then it's just slope itself. So it's pretty easy for the first one. The hard part for take the derivative is the second one, because now Q is in the denominator. I'm not sure whether you guys still remember the function. When you take this function, in fact, if we rewrite this function, is ds times Q negative 1. Q negative 1 means 1 over Q, right? If we take the derivative of this function, well, we should get is, we take a negative outside here, so it's still ds, negative just negative 1, so it's negative 1. Negative 1 times ds divided by Q2. That's function, in fact. So, but anyway, so you get H over 2 minus DSQ square equal to 0. Because we have to set this equal to 0. And now we can easily solve this problem, which you will get Q equal to 2ds divided by H square root. It is how we get this. Maybe the only hard part or some part you forget from calculus is that how to get the derivative for this function when the variable is in the denominator. But if you review calculus, it's pretty easy. So it's not so hard. Even we don't require it's not so hard. Just want to let you know, okay? But we will level test this part in school business, at least for my class. I'm not sure about the econ or some other class. Right? So we have discussed, right? This, even if you don't understand why we take derivative equal to 0 on mathematical way, we can explain the business way. We have discussed on last Wednesday class. Okay, it makes sense when demand increase, our optimal order quantity should increase. Because think about the extreme case, if demand is huge, then we should order more every time. Otherwise, we can't satisfy demand, right? When S increase, which means the one-time ordering cost increase, you want to order more per time. Also makes sense if your ordering cost is extremely large, right? You don't want order so frequent. You want what's less frequent as less as possible. The third scenario is H in the denominator. When holding costs increase, then it's Q increase or decreasing. When H increase,
Decrease.
A holding and Q decrease. Great, Jack. So it also makes sense if you have a really large holding cost, okay, you want to hold as little as possible, right? You don't want to order more, right? So then optimal order quantity should decrease. So that's this scenario. Okay, even we are not so sure about the mathematical procedure to get this solution. That makes sense from business. Now, we have this example. Right. We know here is our optimal equation or formula to calculate Q. Now, let's see this example. A local distributor for national tile company expects to sell about 9,600 steel-belted radial tiles of a certain size and trend design next year. So annual carrying cost, so carrying cost is the same as the holding cost. Okay. The annual carrying cost is $4 per tile, and the ordering cost is $75. You understand? This is the one-time ordering cost, right? The ordering cost is $75. So the distributor operates 288 years a year. First question, what is EOQ? Economic order quantity. So you just plug in into this formula, you will get the optimal Q here. And the second, after you get this optimal order quantity, you have to tell the manager, tell the client, how many times per year to order. Well, that's the second decision, right? When to place order, right? You ask me the quantity, but I need to also know how many times have you place the order, okay, for next year. And what is the length of an order cycle? Anybody can explain to us what is order cycle mean? What does order cycle mean?
From like the point you like you make your next order after your inventory.
Just the time between two orders. So that's the order cycle. Like you place order this Monday, place order next Monday, that means 7 days or 1 week is your order cycle. Great, Bernard. So the last question, okay, what's the total annual cost if EOQ quantity is ordered? So then after we get this Q, we just plug this Q into this formula, which is TC equal to Q over 2 times H plus D over Q times S. Then we get the total cost. Oh. All right. Any question before I give you time to begin to do the exam by yourself? Any questions?
So wait, so which formula do we use for part A?
Which formula?
Or
That one.
that one?
Yeah. It's EOQ.
Sorry.
That's only one formula we have
Okay.
learned so far, right?
Gotcha.
In this chapter.
Alright.
EOQ is the economical optimal order quantity. So it's the
Okay.
optimal order quantity. It's here.
Got it.
Right.
Alright.
Any other question? Very good one. Any other questions? Okay. I give you guys 10 minutes. First try to do that. It's not a easy one. QDS, what is D?
I mean, H is carrying cost of holding.
Yo, so much yesterday. Carolina. Dude, it's felt like I was gonna fight
D is the annual demand, right?
I don't remember doing that.
Yeah.
I do your question, I want to
S and H. S.
See that?
What is that? Look at it. This is the what? It's the which course?
Yeah.
S is the ordering course.
Holding cost?
So
That's what you told me H was, bro. What are you trying to
75.
No, H is carrying cost.
What's plus H? Yeah. That's
Exactly. My boy.
Same with Kim, you know.
I know, I'm sorry. That shit.
That's great.
That's not right.
Yeah.
Oh, okay.
So what is D?
I thought D would be
In a little bit.
4.
D is the
Same.
demand. Right?
Break the street.
D is for D represents demand.
Okay. So it'd be 96.
Yeah.
Gotcha.
Hmm. Good. What's his regular Q?
Is that a 2 or 80
Okay.
in there?
That's great.
Yeah.
Alright, so that'd be 2 signs.
9,600 times 75
How many?
divided by 4, take the square root of 4. Which one are you?
You have to plug in this formula. Q0 equal to square root 2ds divided by h. That formula will give you the optimal order quantity, which is EOQ. EOQ represents the economic order quantity, so it's the same as Q0. So just calculate this by using this formula. This is total cost. That's for past D. Okay. Before you finish your first three passes, you will never touch the total cost function. So you should first do the first one because EOQ represents the economic order quantity, which is Q0, the quantity. So you should first use the formula you already right here. Use this formula to calculate the EOQ, the optimal quantity. Okay.
Okay, but you said the optimum quantity is just the Q. Okay.
Q is the quantity, right? Q represents the quantity. Yeah.
Okay.
When it has the subtitle 0, somebody will use Q star, whatever is the same as the optimum. So
Okay.
that means, I think notice 0, that's probably is O. Okay. Q O, so it's Q optimal.
Oh, I'm sorry.
Yeah.
Q optimum, I'm sorry.
I guess so. But I used, when I write paper, I use Q star because it's optimum. But anyway, you understand. Q is a quantity. EOQ represents economic optimal quantity.
Okay.
Economic order quantity. So the first quantity is the same as quantity. So it's the same as to plug in this formula to get the quantity.
Okay, I appreciate it.
Can you check this?
This is microeconomics. Right.
600. So that's great. So yeah.
So,
Great.
no idea.
Great work.
For the rest of them?
Yes. What? All correct.
Yeah, just
Okay.
total number of.
So EOQ is this one,
I
right?
have a top.
Agree?
Order quantity
And then what is the D?
gives you the order quantity.
That's correct.
Yeah. C
What
is
about the
reduced,
S?
So like, B is asking you
No.
how many times.
Yeah, S is ordering cost.
So you have
4
to
is
take
the holding cost of
the
carrying.
number of
So
Q0
what should be the zero?
divided by the output.
Okay.
So like the number of units and it's the number of days, that's your period, like how long is
Great.
the
The first step is also I believe it's correct.
So it says that the distributor operates 280. I ain't got time for that.
Ew, nah.
So that's more than enough to meet that amount.
Alright, hold on.
The first is correct.
So you have, you're ordering it 16 times, so you're doing
Yeah, yeah.
bottom right. You know
Yeah, yeah.
what I'm saying? And then
Back the way 2 days.
so you got
What are you doing? You throwing just in a river?
Teaching
Basically,
That's right.
I thought she died. Something happened. I was like, damn. Let me see. 600 over 75.
So we actually need,
Man, that was not rough. Then did you see what happened to Michigan? Michigan State.
Oh yeah, I've seen. I'll be watching.
That's probably the saddest finish probably in the history of football.
This is your pirates, right?
The punter kicked the ball after he
Okay.
muffles the punt.
The reason you're confused, you
That's
change your
what
house too. I'm just kidding. C. B is correct. C is not correct. So
That was
B,
sad, man.
you already used
And then he
that.
received death threats
Okay,
too.
B is C. Think about it.
Dude, you got the pump block.
That's
Yeah.
something you have done.
For real?
You already used. Okay, very good.
Sad, man.
Terrible.
It
That's
is.
really terrible.
That's the order cycle. It's gonna be very straightforward.
I mean, it ain't his fault. If anything, it
It's
should
D.
be his mom. Like,
It's the-
Yeah, he dropped it.
How many
I
days?
didn't even see it. So
It was a low year, right?
I mean,
I just see when they picked it up.
This year.
I mean, he only had one
What
job.
is the order cycle? You already
Hold
passed
on to the
from
ball. At
pass
least
B.
when you muffle it, like don't try and punt it again.
How many will you have, right?
Just freaking go down.
Do you want
down.
this? You
That's
already
your
have
defense.
Fourth down,
something.
bam,
the
that's it.
dance.
Instead of defense.
How many
It
days
could be
between
cool.
two orders? You understand? You think about okay, if you have like 30 days,
Like no time.
right? Just think about minus
Yeah.
one.
It was like no
So
time.
30 days.
Right,
If you
yeah.
place the order 3
All you have
times,
to do
then
is
how do you
go
calculate
It said it was only
the order
one-
cycle?
it was a
It's 30
four-time
divided by 3.
finish.
Right? Because you 3 days you place 3 order, that means you have to
Yeah.
wait 10 days.
Almost
Every
broke.
Yeah, but Auburn
how do you guys
Alabama was
decide?
like-
In 30 days divided by 3
You
orders.
had like a chance.
Right? Now we have
This
annual
this
is
one was just
288 days
air.
divided by what?
Like,
Yeah.
you've been watching.
Adventure school maths again, right?
You've been watching the playoffs.
I'm in the Nets. I'm not in the Nets fan. I mean,
No.
I support them.
So the problem is that so
Going for the Mets over the.
here,
Man, then
Age.
I'm
Cubs.
Age is holding.
Might as well.
What is holding person?
Pull from the Cubbies.
Cubbies. I'm gonna wear my Nets gear tomorrow.
Holding as the
I wouldn't
same
mind
as
either one.
carrying cost, right?
Oh, okay.
Carrying something is
Yeah.
holding.
I am pulling.
288 is how many days, so it has nothing to do with the cost,
Yeah,
right? Okay.
Yeah.
That's what I'm.
Okay, I'm seeing many students have finished this question. Very good. So, any volunteer for part A? That's the easy part. Want to be the volunteer? Easy part. A volunteer for easy part. Huh? You want to be the hard part? So, any volunteer for part C? Nobody, right? First part A, still part C. Anybody? Okay.
You want me, do I
Those
just
you,
tell you?
look, any volunteer, I don't call you. If you really don't want to speak out, that's fine.
Do I have to get up, or are you just?
Just speak out, right? Okay. I know you have got the correct answer.
Alright, so the EOQ equals, 2
Uh-huh.
times 90, or 9,600, times 75,
Mm-hmm.
divided by 4, and you put that in the equal 600.
Very good. Okay. So it's D's demand is 9,600 okay, tiles per year annual demand. S is ordering cost, which is $75 per ton per ordering. And H holding cost here is a little bit confused because they use the terminology is carrying cost, but you understand holding carrier is the same, right? Sleep in your inventory, sleep in your warehouse, that's the cost. So plug in this formula, we get EOQ equal to 600. Great. Pass B. Okay, that's probably is the easy pass. After we get pass A. Any volunteer for pass B? Okay. That's not really have volunteer. Aaron.
You take the demand,
Demand?
9,600,
Mhm.
and you divide that by the EOQ.
Mhm, great.
So 9,600 divided by 600, which gives you 16 orders a year.
16 orders. Okay. The explanation is very clear. You think about that. If you want to calculate how many times you want to place order, simply, okay, you know the annual demand. You know every time how many you will order. Then use the annual demand the EOQ or optimal order quantity. You get, okay, how many times I need to place order? That's 16 times, right? Part C can be a little bit hard. Well, still, first, it's not hard at all. In fact, if you look at that, finally, it's elementary school math. But initially, it maybe seems very confusing for us. Any volunteer for part C?
I'm starting myself.
Jack?
Since it would took 16 times per year to order it,
Mm-hmm.
and you're only open 288 days a year for operation,
Mm-hmm.
then you know that you divide the 288 days divided by your 16 times per year based off your cycle, and so your cycle becomes 18 days.
That's great. I don't need to explain further because Jack's explanation maybe is better than my explanation. It's very clear, right? You operate 288 days, right? And you have to wait every 16 to place another order. So you have to place 16 orders. Then how many days you need to wait for another order? That's 288 divided by 16, which is 18 days order cycle. Now you almost answer all the questions your manager probably want you to answer. Okay, first question, definitely is, how many you want to place order? 600 every time. Now manager, okay, I know how many I need to place order, but how frequent? How many orders I should place? That's part B and part C. First, you tell your manager, okay, to satisfy our customer demand, we have to place 16 orders. Second question. And then you have to wait 18 days for every order. Now, the last question is your show time. You want to show your manager, okay, by using my method, you will get the minimized total cost. Any volunteer? Minimize total cost for part D? Anybody? Aaron?
I'll try. I just took the ordering cost of 75 and multiplied it by your number of orders per year, 16.
Mm-hmm.
And then added that to the annual carrying costs, which is
$4?
$4 times 9,600. Would it be 600?
Should be 600 divided by 2, in fact.
Oh, because that's that.
The reason is that I think you think out of box, but very good. Because you want to figure out the total by yourself, but in fact we already have this formula here, right? So the holding cost is Q over 2, while Q equal to 600 over 2 is your average inventory level, right, times holding cost. And the second part is you already figure out correctly, even you don't direct plug this in because D over Q already calculates here, 16, you plug this in. How many order you place? Times 75. Okay, but if you are not familiar with that, I would suggest you just follow this formula. So it's the same, right? So it's Q over 2 divided by A times H plus D divided by Q times S. And what is the final result? Anybody can tell me?
2,400.
2,400. Very good. So it's your show time. You tell your manager, by using my method, you can reach the minimized cost. There's no way you can have a lower cost than this $2,400 because we can guarantee it. Okay, probably you want to show the calculus, but probably not. But they can understand. Okay, this is the optimal order quantity. How to define optimal? To minimize your total cost. Okay. That's your final result. Now we answer all the questions for our manager, right? Which is good. Any question or comments for the EOQ? I can guarantee you that in our second exam, you will see the question of EOQ. That's for sure. That's for sure, right? Huh?
Is it in our homework?
Definitely. Homework. You should answer this question. Ask this question, right? Homework, if there's no EOQ, probably I can't give you any homework questions. Okay? But don't worry about homework. Yeah? Any more questions? Comments? Good? Can we move on? Okay. Okay, now we move to the second type of EOQ, which is called the EPQ model. As we have discussed, EOQ is so useful if you are in the position you have to place order or order is the most important decision for inventory management. But if you are in the position as a manufacturer, then definitely you still need to place order. Okay. Why manufacturer need to place order? What type of order he or she need to place? Manufacturer. If you are a manufacturer,
Raw materials.
raw material, very good, or components, right? You still have to place an order for raw material, but we have talked about in the beginning of this chapter. We say there's so many types of inventory: raw material, work in process, maintenance inventory. But what's most important inventory? Finished good, right? That's why if you are in a position of manufacturing, you have to place order from raw material, but this is not the most important decision for you because the most important decision for you definitely should involve in finished good, right? Okay, that finished good you have to do the production. Now we have to determine, right? If you are in manufacturing, you have to determine how much to produce every time and how long you have to produce. If your capacity exceeds its usage, this makes sense. Think about, right? We want to Coca-Cola, right? Even Taco Bell. One machine, soda machine, can produce like 10 different soda drinks. If you have chance, some of you maybe have chance to went to Coca-Cola Center in Atlanta, you will see a magic machine. They have all sodas for these 5 continents: Europe, Africa, North American, Asian, South Latin America. Right? I personally really don't like the African taste of the sodas, but you can try. So one machine, they have the capacity to produce different products. Okay, then you have to schedule machine or people, right? To say, okay, Monday we produce like Coke, and Tuesday like maybe spritz, so different products, or Wednesday water. Then you have to schedule these things. Then we need to use the EPQ model. There's some assumption very similar to the EOQ model before we can use the EPQ model. First, we only consider one item. This is very easy. If you consider 2 or 3 items, you just use the same formula for the second item, third item, fourth item. Any demand is known. Okay, let's say we have very perfect or close to perfect demand forecast. Same. Okay, usage rate is constant, which means our daily demand is the same. Continuous usage. So demand happens every day. So you consume Coke every day, but our production just occurs periodically because our machine has a huge capacity. If you will produce Coke 24/7, we will exceed our demand. We shouldn't produce Coke 24/7, right? We produce Coke one day, and the second day we produce another type of soda. The production rate is also constant. That means, okay, it's very stable machine output rates. Lead time is fixed, same as EOQ, no quantity discounts. Very similar with EOQ model's assumption. But the graph now is very complex. We probably need to spend a lot of time before we can move to the next slides. So, visual demonstration is very important for us to understand any business model, especially inventory model. Right? Even when I write a paper, even like to the top journal, sometimes we also need to draw the picture, something like that, to make even the readers, other professors, when they read our paper, easy to understand. Here is the inventory and the production graph for the EPQ model. Now we are thinking about the manufacturer. So you are manufacturer. Then you have one decision is the production quantity. QP is the production quantity. You have to determine how many units you want to produce, and then you stop the production. Right? Then let's say this is 500. Right? You produce until 500. This point, and you stop. Let's say the cycle is 1 week. You spend the first 2 days, Monday, Tuesday, you produce 500 and stop. Okay, so this dashed line is your production quantity. Right? Every hour increase until you produce 500 units, then you stop. Right? On the other hand, that's the usage rate. It didn't show in this picture, but demand also happens simultaneously when you produce. You also have demand. Customer want to order. Right? Since there's demand, so your inventory level, your accumulated inventory level is not as high as the production level. So this solid black line is your inventory line. So you can see that when you produce a lot, but on the end of Tuesday, you don't have the same amount, say 500 of the inventory. The reason is that the customer consume this amount in these 2 days. Right? Because think about, like say, if your demand rate, like say, demand rate is 10, let's say 100 per day. So production rate is 100 units per day. And if your demand rate is 50 units per day, right? Then my question, if you produce 2 days, produce your product for 2 days, at the end of the second day, how many on-hand inventory do you have? 100, right? How do you guys 100? 50 times 2, right? Because every day you have the leftover inventory equal to the production rate minus the demand rate is 50. So at the end of the second day, you can see here, we have on-hand inventory. But this on-hand inventory is much lower than our total production quantity, which in this example 200. The reason is that in the same time we produce, we have to ship out or satisfy customer order. So that's why in this solid black line, which is the inventory position, is lower than our production quantity. Now, from Wednesday to Sunday, let's say this 1 week, okay, we stop production. Our inventory continues to go down because we have to satisfy our customer's demand. Until the end of Sunday, our inventory becomes 0. Okay, we use all our inventory to satisfy our customer. We begin the next cycle, production, inventory, satisfy demand again. So here is the explanation of this picture. It's clear? Any question, comments? I believe it's not clear enough. It's usually in the first round. Let's have the second round. Question? So we have a lot of genius in this class. No question for this complex graph. Clear for everybody? No? Not clear, just ask questions or raise some discussion.
What did you say the max was again?
Oh, max. Okay, good question. I forgot to mention. Imax is the maximum inventory level. So this black solid line is inventory level, right? When do you reach this maximum inventory? When will I reach the maximum inventory? It's the time. Yeah.
Oh, I was just gonna answer your question. Isn't it once you get the top number of how many units you produce?
This one, Imax?
Yeah, or never mind. I guess that's a Q.
Yeah, Q is the maximum units you produce. QP is the production quantity.
Oh, okay.
Production P quantity. Right?
Okay.
So QP, here is the points you maximize production level and you stop production.
Mm-hmm.
The question for MX is the maximum inventory level. Maximum inventory level, you reach the maximum inventory when you stop production. You think about, you begin to accumulate your inventory when you do the production. When you finish production, the only action is that you consume your inventory because customer demand is still happening. But you stop production here. So from Wednesday to Sunday, your inventory level continue to go down. But the maximum reached maximum of inventory level reached at the end of Tuesday, which is the end of your production. Is it clear for you? Right? Because when you produce, okay, on the other hand, you also consume your demand. But since your production rate is higher than your demand rate, you continue to build the inventory. That's your highest level is that you stop production. Now, you will consume your inventory to satisfy your customer demand. So you can see here, so maximum inventory level is at the end of this production cycle here. Okay, very good question because we have to use this Imax, a maximum inventory, to calculate our optimal production quantity. And you think about Q, this Q itself will not affect our cost. The only thing or the most important thing to affect our cost is inventory level. Right? It's inventory level. But inventory level is not an independent variable. It's dependent on production rates and demand rates. But production rate and demand rates, we can determine the inventory level because it's just a difference between production rates and demand rates. Any other questions? I don't want to go too fast because this can be a little bit confusing or complex for some students. Any other questions? No? Clear? Let's first move on. We can go back anytime if you want. Now, our goal is still the same, right? We still want to minimize our total cost. But even the total cost components are still the same with the EOQ model, which is the holding cost, carrying cost, plus setup cost. Well, setup cost is very similar to ordering cost. Think about here. Now it's not place the order, but every time you run the machine, you have a setup cost, right? Change the machine, tune the machine, and put the employee, appropriate employee on site. Oh, that's the setup cost for one-time running of the machine. Okay, and if the one-time setup cost is S, same as D over Q times S is the annual setup cost. Well, the hard part for EPQ is to calculate carrying cost or the holding cost. EOQ, if you still remember, the holding cost is very straightforward, which is Q divided by 2 times H. Because we know the every inventory level is nothing but Q over 2. You place order on up to Q and you consume the amount until 0. So your every inventory level is nothing but Q over 2. That's for EOQ. But EPQ, we know. Now the production quantity Q can't determine our inventory level. It's different. The dashed line and the solid line, right? Then we have to calculate the maximum inventory level divided by 2, which is the average inventory level. So how do you calculate the MX is our question, right? As we have discussed in this simple example, MX is determined by the difference of production rates and the usage rates or demand rates. So this is the formula to calculate MX, maximum inventory, which is P minus U, production rates, minus usage rates. So that means, let's say the rate is per day, okay. For 1 day, what's the difference? How many inventory you can accumulate for 1 day? P minus U, sorry. P minus U is the per day accumulate inventory level. Clear? Clear for you?
Yes, sir.
Clear?
What's U?
U is the usage rate. I should change it here. It's not the same as demand rates, but the textbook uses usage rates.
So
It's
for production quantity, it's U, and for EOQ, it's demand, right?
production quantities, production rate is P.
No, I mean for the formula, right? For the formula for EOQ, we were using demand.
EOQ or
Right.
EPQ. EOQ is the last
EOQ, we
one.
were using demand, right? And then this one we're using usage.
He's just saying if it like correlates, pretty much, right?
EOQ is not demanding effect. EOQ is Q over 2 times H. Why? Let's see the picture of EOQ. So EOQ, you place order of Q, right? And then Q is already your maximum inventory. We can use the same terminology for EOQ, but it's pretty confusing. Q is the same as MX for EOQ. If you place order of Q, you receive that Q. Right? So the average inventory level is nothing but Q over 2. That's why for EOQ, our total holding cost, carrying cost is Q over 2 times H. Clear for you, Jack?
Sure.
But EPQ is different. We have to calculate maximum inventory level because now we also have a Q. It's our production quantity. But we know that from this graph, if we use QP over 2, it's not your average inventory because we never have the inventory level as high as QP. Because when we produce, the same time we consume. So we will never have inventory level as QP. Even it's our decision variable, we have to tell the story, tell the decision, okay, how many QP we want to produce, but this is not inventory. So we have to calculate inventory, IMAX. So that's the difference between the EOQ and the EPQ. EOQ here is not IMAX, it's just Q.
So QP will be given then.
No, QP is our decision variable. We have to calculate the optimal QP. That's our purpose for this model. We have to calculate, okay, let's say, how many soda you want to produce before you stop? 1,000? 2,000? You have to tell me if I'm the manager, right? That is the decision variable. Right? But you can see here, after you decide QP, you can calculate the maximum inventory level by using this formula. Clear for you? Jack, still have question? So QP is the decision variable. We have to use calculus the same way. Calculus what is the optimal production quantity. That's our decision. As manufacturer, right? We have to, our decision is how many we want to produce, before we run this machine for another product. Now who can tell me, okay, why Mx equal to this one? What is QP divided by P mean? QP divided by P.
It's quantity divided by like your entire.
Production or delivery.
QP is the quantity, right? Production, how many
Yes.
units you want to produce?
Right.
And the P is the
Pretty much.
production rate.
Yeah.
Let's say how many units produced per day. Then what's the ratio mean? QP over P. You think about it, let's say you want to produce 1,000 and you stop. And your production rate is 200 units per day. Then 1,000 divided by 200 equal to 5. What does this 5 mean?
How many? That's the final number of how much you're gonna be produced per day. Well, I mean,
Produced per day is P, so it's
I
production
mean,
rate.
I'm sorry. When you get that 5, that's how much you will actually have finished. And then
How many days you produce? That's right.
Yeah.
Yeah, how many days you produce? Because it's, you say your goal is to produce 1,000 units, and every day you can produce 200, right? 1,000 divided by 200, that means okay, you have to produce 5 days,
5 days.
then you stop.
Yeah.
Right? So Q over P, if you go back to our graph, is nothing but just this green area. How many days you have to produce, right? 1, 2, 3, 4, 5 is determined by Q over P. And the P minus H is the difference of production rate and usage rate, which is the same as the slope of this black line. The slope of this black line is in fact equal to P minus H, P minus U. Why? Why the slope of this inventory line is P minus U? This is a straight line, right? Inventory line is a straight line. Why the slope is P minus U?
Wouldn't the line be the way it is because you're actually getting production done, but are you talking about the like decreasing slope or the one in between?
Just the first green part.
Why is it?
So why the slope is because you're increasing production, right? Those are the days you're working.
Yeah, you have production, but on the other hand, you have the usage, right? So my question is, why is P minus U is the slope of this line, inventory line?
Since everything's constant, since we're saying everything's constant,
That's right.
it's just a linear value. So when you subtract it, it's going to be the same no matter what the points are. So it just winds up being your slope with production minus usage.
That's great. Yeah, I think Jack's place very clear. Yeah, let's make additional comments that because inventory, think about just one day. Let's say one day you have 100 units, your production, and the usage is 50. A very simple example. So at the end of the day, how many inventory you have? 50, right? How do you get that? P minus U times 1 because you have 1 day, right? That's your point. After 1 day, P minus U times this how many days, right? So the slope for here is nothing but the difference between your production rate and the usage rate. Then we understand why Mx is equal to here. Here is the slope. Here is how many days we have green. And we know this is x, right? Well, x is how many days we have QP over P. Determine the x here. And the slope is P minus U. X times slope, y value, Mx. So that's why Mx is calculated in this way. It's the slope here times how many days if you stop production. So we get Mx here. I hope it's
QP over
clear.
P is the number of days.
Mm-hmm.
QP over P is the number of days
Yeah.
for production.
That's right. Any questions? We can go very slow. We should go very slow because it can be very confusing. Because now we have two lines, production line and the inventory line. And we have two rates, is production rate and the usage rate, or called demand rate, whatever you want to call. So it can be very confusing. And also, you have the homework question, you have the exam. So I want to go very slow before I can make at least most students clear in class. If you are not clear, it's fine. You still have time after class, or we can discuss in my office. But I want to everybody at least have this kind of impression. Okay, we calculate this maximum inventory. The reason we calculate because we can't use Q direct to get the maximum inventory. when we produce on the same time we have the usage rate, we have demand. So Q counts determine our inventory level. This is the difference between production as a manufacturer or retailer. Okay. But we can calculate our inventory level by using all the information like QPU. That's the way to calculate. First, we calculate how many days we run our production if we determine QP. It's easy, right? You have determined how many units you want to produce up to, divided by the daily production rate. That's QP over P is how many days you produce. Very simple example like QP equal to 1,000 and the production rate is 200 per day. Then we know, okay, totally equal to 5 days. Agree with me? Right? 5 days. Now we know that, let's say this green area, now from this example is 5 days. And then next we have to calculate the slope when we accumulate the inventory. Every day the slope, if the usage rate is equal to 100 per day, that means every day we accumulate 100 units of 100 inventory. Every day, which is P minus U. Then the question is, what is the maximum inventory? The maximum inventory reach until the end of the 5th day, when we stop production, right? So at the end of the 5th day, we have 5 times 100. Difference between P and U, which is 500 is our maximum inventory. You can see here is Q over P times P minus U, which is 5 days times 20, 200 minus 100, sorry, which is 500. At the end of the 5th day, right, you will have the inventory level equal to 500. Because every day you accumulate 100 units of inventory. So at the end of the 5th day, you have 500 units. So I think that's pretty much, because I understand many students already got that 10 minutes ago. But I just want to make sure everybody is in the same page. Question, comments? Good? Okay. Very slow, but I hope it's helpful, at least for your homework. Okay. See you guys on Wednesday.
Is day one usually Monday or Sunday?
Huh?
For companies?
Very good question. Many companies I have seen still Monday.
Monday?
But many of their plan is done by software. And definitely some people handle on Sunday. So in fact, you can think about they run 24/7. But usually when they talk about cycle, it's weekly cycle. It's still beginning.
When is homework due?
Huh?